Hello, my darlings. So today we're going to look at reviewing graphing inequalities. Then we're going to look at graphing systems of inequalities. And finally, we're going to graph those inequalities and systems on our TI-Nspire calculators. Okay, so here we go. The first thing we want to do is we want to quick review what each of these four symbols in the boxes here represent. So we have here y is less than. Now if y is less than something, it's smaller or below it. So when we graph the line, we're going to then shade below. But notice also, it's only less than, it's not or equal to. So our points on the line will not be part of our solution set. So we don't graph a solid line, we graph a dotted line. So that means we would graph a dotted line like this and then shade below the line. We might also instead have a decreasing line, but again, where the values are going to be less than the line is going to be below the line. Now, if we look at the second box, we have y is greater than. So if y is greater than, it means y is above it or a larger value, which means we are going to shade above the line. And again, there's no or equal to, so any points on the line are not in the solution. So again, we're going to graph a dotted line. So we could have an increasing dotted line, or we could have a decreasing dotted line. But when it comes time to shade, this time the y values are greater than the y values on the line when we shade above. So all the points up here above the line would satisfy the inequality. Next up, we have y less than or equal to. So just like in our first case where we had a less than, we're going to shade below, but this time this or equals to is going to tell us to use a solid line. We could have an increasing solid line or a decreasing solid line. And this time we shade below and we shade below. So any points in this shaded region or on the line would be solutions. So in our first four examples, only points in the shaded regions could be solutions. But now that we have a solid line, points that are also on the line can be a solution to the inequality. And the last one is y greater than or equal to. So since y is greater than, it's going to look like our second one. We're going to shade above. And since there's an or equal to, we can be on the line. So we graph a solid line. We can have an increasing line or a decreasing line. We shade above. We shade above. And any point on the line or in the shaded region would solve the inequality. So those are the only four possibilities when we go to graph an inequality. Now, when we ask you to solve the system of inequalities by graphing, you're going to take each inequality and graph it individually and then look at the areas that they have in common. So let's take a look. If we have y is greater than x plus 5. If it was an equal sign, it would be real easy. We would know that the slope of this line is 1 and our y-intercept is from that plus 5. It's 5. Now, if we look at the inequality, y is greater than means we're going to shade above. And since there's no or equal to, we're going to use a dotted line. So we're going to go on our, let's label our x and our y-axis. On our y-axis, 1, 2, 3, 4, 5, we put a dot. We know our slope is 1. We're going to get our line. So now we connect our dots, graph our line with a dotted line. You do need to remember, however, to label that equation, but we're going to label this with a y equals x plus 5. And don't forget, we are shading above above this graph. So far, all our solutions are the points above this line and not on this line. Now let's take a look at y less than or equal to x minus 2. Again, this line has a slope of 1 and a y-intercept this time of -2. Since this is a y less than, we're going to shade below. It's y less than or equal to, and the or equal to tells us to use a solid line. And if we plot the points, we start at -2. Our slope is 1. We draw our solid line, label the equation y equals x minus 2, and we shade below. Now we said that our solution is going to be in the common area. Unfortunately, we don't have a common region. We have at the top part and we have at the bottom part, and neither of those shaded sections intersect, which means this system of inequalities actually has no solution. I know that's mean of me to start with one that has no solution, isn't it? Okay, let's try one that does have a solution. So if we have the inequality x greater than or equal to 0, remember that's like the line x equals 0. That's a vertical line. And it also happens to be, by the way, the y-axis. Now that greater than or equal to, the or equal to tells us we're going to use a solid line, but the greater than, now here's the thing, when we have a vertical line, you can't shade above it. So we would have to either shade to the left or to the right. Now if you think about our x-axis and the numbers on the x-axis, here's where x is 0. Are the numbers that are greater than 0 to the left or to the right of that spot? They are over here to the right. So we are going to shade to the right. Okay? And it's only when you have vertical lines that you have to worry about shading left or right. Okay? So let's get our line, and we're going to grab the line here on the y-axis. We're going to label this appropriately as the line x equals 0. Then we're going to shade everything to the right. So far we know that our solution would have to be in the first or the fourth quadrant. Let's take the next inequality. Y is greater than or equal to 0. So that's going to be similar to the line y equals 0, which is a horizontal line. And because it's equal to 0, that happens to be the x-axis. Okay, now it does have an or equal to again, so again we're going to have a solid line, and since it is a horizontal line, when we're looking for greater than, we're going to shade above. So here's our line y equals 0, and we're going to shade above. So now we do have some overlap now. The overlap is in the first quadrant and the origin. So far, that's where our solution can be. And on the positive part of the y-axis and the positive part of the x-axis. We have one more inequality. X plus y less than or equal to 5. Well, if we were to graph this line x plus y equals 5, to find the x-intercept, we let the y be 0. So we would have x plus 0 equals 5. The x-intercept is 5. And similarly, the y-intercept is also 5. So we go 1, 2, 3, 4, 5, put a dot. 1, 2, 3, 4, 5, put a dot. Now we're going to get our straight edge and graph. Don't forget to label x plus y equals 5. Now we forgot to say, we have this less than or equal to. Since it's or equal to, we're going to have a solid line. And since it's less than, we're going to shade below. So we're going to shade underneath this line. And now if we look to find our common region, it's this area on the lines, and inside that triangle, I'm going to put a big S for the solution set. There's our solution. The edges of this triangle, since all the lines were solid lines, as well as the area inside that region. And there we go. We have found our solution to the inequality. So next up, we're going to pull out our TI-Nspire handhelds and we're going to review how to graph inequalities on the calculator. Okay, go grab your calculator and let's go. Okay guys, so we're going to add a graph page, and here we go. Now notice in our entry line it says f1 of x equals. What we're going to do is we're going to use the delete key, the backspace, and we're going to backspace. And you'll notice here we have all the different types of inequalities we can have. And notice it's also going to change it from f1 of x to y because we're no longer dealing with a function. Now we're going to graph the inequality that I've given you. Y is less than or equal to 3x plus 1. So we're going to choose the top option. Y is less than or equal to 3x plus 1. And we're going to press enter. Notice we have a solid line and we're shading below that line. Okay, so it's automatically going to do this for us. If I was to tab back up and arrow back in here, if I went back to this inequality and instead of less than or equal to, if I put in control equals to get my inequality symbols, and I just put a less than symbol and press enter, you'll notice now we have the dotted line. So the calculator will show us whether it's solid or dotted if you put the inequality in. Now I also want to add another page. Control Dock, we're going to put another graph page in. And I want to draw your attention, remember, you can also graph the inequality 3x plus 2y less than or equal to 4. You could do the algebra and get the y by itself, or go to Menu, Graph Entry Edit, Relation. And now we're going to type it in just as I gave it to you. 3x plus 2y. We go control equals to get our less than or equal to symbol and press the 4, and we'll have a solid line. We'll shade below, and we did not have to do any algebra. So this is wonderful if you're not sure or you forget and you want to double check which way you should be shading. Is it solid? Is it dotted? Wonderful. We're going to add another page, Control Dock, and it's going to be a graph. Now we're going to look at the system. Y is greater than negative 2x plus 4, and y is less than or equal to x minus 2. So we're going to backspace over the equal sign, and our first inequality was y greater than, so we're choosing choice 4, negative 2x plus 4. Okay. And I'm going to, let's hit enter, what the heck. So I'm going to show you a little trick here. Since this is a yucky, boring color, I'm going to point at the dotted line. Since I'm on a computer, I have to right click. You on your handheld calculator, you're going to control menu. So point at the line, control menu, choose color, line color. If you just want to change the color of the dotted line, we can change that to blue. Click somewhere else or escape. Point at it again. We're going to control menu again. Color, this time the fill color, change it to the same blue. Now you don't have that boring gray dark color. Okay, so if you like colors, that's how you change it. Now we're going to tab back up. Now notice it doesn't show up as an f1 of x or an f2 of x because we've already told the calculator that on this page we're doing an inequality, so we would have to change it back to functions if we wanted a function, but we don't. We want another inequality, so we now have to type the y. We have to go to control equals to get our inequality symbols. We want less than or equal to x minus, make sure you use the subtraction key and not the negative, minus 2, and hit enter. We now have our solid line with the shading below. We can see that our final solution here is in this purple area. That's where our layover is. But now I know one of these lines is dotted, but I do want to point something out. So I'm actually going to go up and I'm going to go back to relation 3, and I'm going to change that from a greater than to a greater than or equal to, right? Because now this point of intersection is a solution because it's on both solid lines, so it is a solution. We all know how to find our points of intersection, right? We can go to Menu, Analyze Graph, Intersection, and there it is. Now you've got the intersection point. Does the same thing happen if we hadn't changed that to a greater than or equal to? So I'm going to tab up, backspace over this, Control equals, greater than. Gonna hide this like we didn't do it before. Gonna do Menu, Analyze, Intersection, left and right, and look at that. In one of the updates, it does do this. If your calculator does not give you that point of intersection, you have an older operating system, you want to bring your handheld calculator into me so we can update that operating system. Unless, of course, you know how to do it yourself from a computer, go for it. But if you are not getting that point of intersection, we need to update your operating system. But here we go. We've reviewed a lot today. We have reviewed how to graph an inequality, how to find the solution for a system of inequalities, and how to graph those inequalities and systems on the TI handheld. Have a great day, everyone. I'll see you soon. Bye.